Hi everybody, welcome to our today's video. And before we go to the content, I will ask all of you to subscribe to our channel and hit the bell icon so that you can get notifications for all of our videos. So today our topic is again LTE Radio Network Design, and today we will discuss how shadow fading basically is incorporated into your radio network design, what is the concept of coverage probability, and how basically variance of the data impacts what kind of fading margin that we select for a particular link budget. So shadow fading basically is the signal dissipation or the signal fade that occurs due to obstacles. So there are multiple examples for that. For example, here is your transmitter, here is your receiver, and there is a mountain. So this transmitter, this receiver is in the shadow of this obstacle. So basically there will be signal dissipation for this receiver. Another example can be buildings. For example, this is your transmitter and there are multiple buildings, and there is your receiver. So again there will be shadowing. So this is the impact of shadowing, and that's why in our link budget we need to basically incorporate it, the shadowing, shadow fading. Now, as you can see that in any statistical analysis we need to see the randomness or the probability of an event happening, and in terms of shadow fading we have the concept called coverage probability. Now what coverage probability defines is that, for example, if we have a particular coverage probability, for example 95%, then 90 out of 100 times 95% of the times we will have a useful, or you can say our path loss, which comes under the requirements. For example, if we have 155 dB path loss requirement for 95%, if we have coverage probability of 95%, then 95% of the time our predicted value will be achieved. So how coverage probability varies? So now if you're planning, for example, a cellular network which provides non-emergency services, then you can use a coverage probability of 75%. So that would mostly in coverage probability for cellular networks you have 75%, you can use 70%, you can use, if you're on the higher side, you can go to 80%. But I will give you an example which clears the concepts for this. If you are planning a mission critical network, for example, you are planning a police network, wireless network for police, you are planning a network for emergency services, you are planning a network for ambulance services, you are planning a network for disaster management services, then your coverage probability will be 95%. In some cases it will be 99%. And the impact of this coverage, increase in coverage probability, I will show you what it does actually. And then we have your variance. In any statistics, the variance of the data will define how much of a margin you include. For example, if you have very high variance, then you will have high margin to incorporate any up and down fluctuations of the signal. So here is a sample graph which basically shows you the concept. So on the x-axis we have the shadow margin, fading of the shadow fading margin, and on the y-axis we have the coverage probability. And these three different graphs actually represent different values of your variance. So what we see is that the variance increases and we have our increasing coverage probability. So what happens is that if we are using 0.8, so if you can see that this is the shadow margin. If you use 0.6, this is the margin. So for a coverage probability of 60%, shadow, the margin will be less. So basically what will happen is, for example, we have 60% coverage probability, we will add 4 dB to the link budget. If we have coverage probability of 80%, then we will add, for example, 8 dB to the link budget, and therefore your cell size will shrink. And if you want to even further go to 95%, then our shadow fading margin will increase further, for example, to 12 dB, and then our cell size will shrink even further. So as you move up the coverage probability, your cell size will continue to shrink, because you want to ensure that majority of your samples are within your confidence interval. So as you increase the confidence interval, that you move it towards probability of 1, your cell size will shrink. So that is the concept, how you basically select your fading margin. And when you use any network planning tool, for example ATOL, Planet, EDX, anything else, it will ask you that if you want to include shadow margin, and then if you click it, then it will give you a percentage of coverage probability, and then you can choose from there what kind of coverage probability you want, and therefore accordingly it will include the shadow margin in your predictions, and your cell size will vary. And you can check in your planning tools, if you increase that coverage probability, your cell size will definitely shrink. So I hope the concept for shadow fading margin, coverage probability and variance is a lot clearer to you now, and we will meet in the next video. Till next time, goodbye from us, and thank you so much for watching the video.